Assalamualaikum and a very good day to everyone. Today, we will to show you how to solve 3 cases using 3 methods in a biostatic, which is chi-square test, will concern sign rank test, and regression and correlation. The first method we use is chi-square test. Chi-square test is a statistical test used to examine the difference between categorical variables from a random sample in the order to judge a goodness of fit between expected and observed result. We concern sign rank test. It is a non-parametric test to compare the data. When the word non-parametric is used instead, it doesn't quite mean that you know nothing about the population. It is usually mean that you know the population data does not have a normal distribution. The Wilkinson sign rank test should be used if the difference between pairs of data are non-normally distribution. The last method is regression and correlation. Regression can be defined as a measurement that is used to quantify how to change in the one variable will affect another variable. Regression is used to find the cause and effect between two variables. For correlation can be defined as a measurement that is used to quantify the relationship between a variable.
Based on the question of the chi-square test, the question asks, could it be that the suits are equally likely, or are these discrepancies are too much to be random? There are a few steps in solving the chi-square test for independence. Firstly, state the hypothesis. For the null hypothesis, there is no significant difference between poker dealing machines that are supposed to deal cards at random from an infinite deck between probability that suits to be picked out are equally likely or random. For alternative hypothesis, there is significant difference between poker dealing machines that are supposed to deal cards at random from an infinite deck between probability that suits to be picked out are equally likely or random.
For step 2, first, we must insert the data of the observed frequency we have collected from the question into this table. After that, to find the expected frequency, we need to divide total counted cards with 5 cards to get the average number. For the next row, minus the observed value with the expected value. Move over to the next row, we need to square the number we get from the observed value minus expected value earlier to the power of 2. For the final row, the answer we got previously divide them with their expected value. We can total the number from here to find the x squared. For step 3, to find the degrees of freedom, number of categories minus with 1. For our question, the number of categories will be 5. Then we minus the 5 with 1, we will get the degrees of freedom 4. Degrees of freedom represent how many values involved in calculation have the freedom to vary, making it important for us to find them so that we're able to determine the critical value for the question.
Move on to the next step, which is the fourth one. We will be determining the critical value based on these 3 factors. Firstly, the degree of freedom in which we have calculated in previous step, and we get 4. Next, for the alpha value, we assume the value as 0.05 automatically since the question didn't state anything regarding the value. Last but not least, we need to refer the chi-square distribution table and locate the degree of freedom first, which is in the left-hand side, and then trace straight until you can see the alpha value of 0.05. Then there you go. This is our critical value. We have come to the final part in solving chi-square problem question, the conclusion. Usually, we have to state first regarding the critical value and calculated value of chi-square. We need to compare which one is smaller or larger. In this case, the critical value from chi-square distribution table just now is smaller than the calculated one. Thus, we need to state about null hypothesis being rejected or failed to be rejected. And from this case, we could say that the null hypothesis will be rejected because the value falls within the null hypothesis rejection area. Then we can conclude that there is significant difference between both of these categories variables, and therefore the suits are being picked out randomly.
Assalamualaikum warahmatullahi wabarakatuh. Now I'm going to present about case study 2. Wilkinson sign rank test, non-parametric test. The question given is, suppose we have ranks of 8 students of Bachelor of Science in Statistics and Mathematics. On the basis of the rank, we would like to know that to what extent the knowledge of the student in Statistics and Mathematics is related. What we show right now is the table of rank in Statistics and Mathematics. Let's move on to the next slide. Before calculating, we need to state the hypothesis. And this is the hypothesis that we came up. For null hypothesis, there is no significant difference in knowledge of bachelor science in statistics and mathematics student in statistics subject between their knowledge in mathematics subject. As for the research hypothesis, there is a significant difference in knowledge of bachelor science in statistics and mathematics students in statistics subjects between their knowledge in mathematics subjects.
Next step, we will start the calculation. We start enter the data that has been given into the table and calculate the difference. To calculate the difference, we need to subtract the rank in statistics by the rank in mathematics. Like the first example, 1 minus 2, then we will get a difference of -1. After we calculate the difference, we need to calculate the absolute difference. To calculate the absolute difference, we just need to make all the different values positive. Next, we calculate the rank of absolute difference. The first step, we copy the absolute difference and arrange it in ascending order. Then, put the number next to it. To calculate the rank of absolute difference, we need to calculate the average number of the same absolute difference. For example, the number 1 and 2 have the same absolute difference, which is 1. Then we add 1 and 2 and divide it by 2. We get absolute difference of 1.5. Next, positive rank and negative rank. To determine this, we need to look at the sign at different and enter the absolute different rank based on the sign.
2 tell test 5% level and equal to 7, critical value equal to 2, and the smallest test statistic is 13. In this case, the test statistic which is 13 is bigger than the critical value which is 2. So, the null hypothesis will be accepted. And we can conclude that there is no significant difference in knowledge biostatistics science in statistics and mathematics students in statistics subject between their knowledge in mathematics subject.
Now, I will show how to calculate using Excel. So here we have 8 bars for rank in statistics and rank in mathematics. So first, I'm going to calculate the difference equal rank in statistics minus rank in mathematics. And I will copy the formula. So you got the different value. And the absolute difference equal ABS, the different value. And I will copy the formula. And notice that there is a positive value here. Now we're going to rank the difference. We want to know which is difference is more extremely and which is this extremely. So I'll be going equal rank the average. We take the absolute difference and I choose 1. We're gonna put the dollar sign around the letter. And I will copy the formula. And I got the rank of ABS different. For the positive rank, I will equal if difference more than 0, rank of absolute difference enter, and I will copy the formula on this and paste. And for the negative rank, we do the same, but we choose less than 0 because the value is negative. And copy the formula and paste. So we got the negative value. The next step we calculate the total positive and negative rank. So equal sum all the positive value, and we got 15. Same to the negative value, equal sum all the negative value, just bracket, and we got 13. And And for the test statistic, equal, mean, open bracket, sum, open bracket, all the positive value, sum, open bracket, all the negative value. So we got 13. And for the sample value, equal, count, open bracket, all the positive and negative rank. And so we got the sample value is 7. For the critical value, we can get it from the critical values table, which is 2. So here the way how to calculate in Excel.
Next, we will explain about case 33, which is regression and correlation. Here is the question. Firstly, we need to state the null hypothesis, alternative hypothesis, and alpha value. For null hypothesis, there is no relationship between the age of the child and the average total sleep time or ATST. For alternative hypothesis, there is relationship between the age of the child and the average total sleep time or ATST. They state the alpha value, which is equal to 0.05.
Then, insert the data from the table to Excel sheet to calculate regression using analysis to back. You will get an output like this. To analyze the data, first we need to read the R-square value. It is stated that R-square value is equal to 0.231171. This means there is 23.11% variation of ATST is explained by the variation of the child's age. It also shows that the regression has low accuracy. Small value of R-square also means that there is weak or no relationship between the child's age and ATST. In addition, we also can calculate the R-square value by dividing sum of square SSR with sum of total square SST. After calculating, the R-square value is equal to 0.231180. Then, we move to significance F. In the summary output, significance F is equal to 0.113577. When the significance value is bigger than the significance level of 0.05, this shows that the null hypothesis is not rejected. Thus, there is no relationship between the child's age and the average of total sleep time ATST. Next, we can analyze the coefficient. In the summary output, the coefficient of this regression is equal to 584.387060. The positive value of the coefficient indicates for every unit increase in independent variable and dependent variable will increase by the value of the coefficient. Thus, the equation of the least squares regression is ATST y equal to negative 5.931896 multiplied by the age x, and then is added with the coefficient value of 584.387060. Lastly, we analyze the graph to observe the residuals. Based on the graph, there is high density of points close to the origin and low density of points away from the origin. The residual plot shows a symmetry plot about the origin. Furthermore, the difference between predicted data and the original data is small. We can say that the plots are mostly balanced. Thus, the residuals model can be said accurate. There is strong correlation between the predicted data and the original data. That is all for regression.
Now, we will proceed with correlation. This is a table of values that have been calculated. The null hypothesis for this question is there is no correlation between children ages and the average total sleep time, while the research hypothesis for this question is there is a correlation between children ages and the average total sleep time. The alpha value is 0.05, the degree of freedom is 10, and the critical value is 0.5759. Next, we will be calculating the R value using the formula shown. then we will get negative 0.480803, which is relatively poor negative linear association between x and y. Lastly, we need to calculate the t value using the formula, and we will get negative 1.7340.